On the morning of May 27, 1931, a physicist named Auguste Piccard and his assistant loaded themselves into a strange contraption of his own design, an airtight metal sphere attached to a balloon. The two men had told the ground crew they'd be back around noon before lifting off and disappearing into the sky. But hours after the deadline, they still weren't back. 2 airplanes were sent after the balloon, but each had to abandon course. With the oxygen supply presumably exhausted and the balloon drifting aimlessly over the Alps, onlookers could only assume the scientists were dead. But they were very much alive, trapped some 15,000 meters above the Earth. They had managed to survive one catastrophe after another, and there were still more to go. Because, spoiler alert, they survived the whole thing. Their flight to the stratosphere may have been a disaster, but it was humanity's first. And in the process, they helped solve one of science's biggest mysteries. In the early 1900s, scientists began to suspect something weird was happening to Earth's atmosphere. Thanks to folks like French physicist Henri Becquerel, they already knew that pretty much everything on Earth is quietly and constantly being peppered by low doses of high-energy radiation. Don't worry, a typical yearly dose is like 20 times below general exposure limits. Scientists just call it background radiation at this point. But at the time, we didn't know exactly where all this radiation came from. Some of it, scientists would learn, came from radioactive elements that just naturally exist in the rocks beneath our feet. Elements like radium and uranium. But some isn't all, and in the meantime, something weird was happening in the air. To understand what was going on, you need to know that radiation can be blocked by air. It's not immediate, it's not like a big lead shield, but generally, the farther away you go from the source of the radiation, the more of it gets absorbed by the molecules in our atmosphere. So if all the radiation came from rocks and buildings, and if you were able to go way, way up into the sky, the radiation levels should go down in a predictable way. I'm simplifying a bit, but that is the gist. However, in 1910, a Jesuit priest named Theodor Wolff carried a radiation counter up the Eiffel Tower and got some weird measurements. He'd done what he needed to, put a lot of air between him and the ground, and the radiation levels did go down, but not as much as they should have. Assuming his numbers were right, there were a couple of explanations. Perhaps up until that point, all the physicists had gotten something wrong about how air and radiation interact. That was pretty unlikely, but the other possibility seemed equally strange. A second, unknown source of radiation pushing the numbers up. A radiation source in the atmosphere itself. But were Wolff's numbers right? There were quibbles with his findings, like if he'd accounted for the metal in the tower, so his data were mostly just ignored. Still, they hinted we were missing something, and if we were going to figure out what that something was, we needed a way to go higher than the Eiffel Tower. A lot higher. In the 10th century, a scholar and polymath named Abbas ibn Firnas tested a homemade glider by jumping from a minaret in Spain, with admittedly some injuries. Others followed suit with their own gliders and parachutes, but these were all more falling with style than true flight. China is reported to have experimented with human lifting kites in the 1200s, but let's jump forward to 1783 when the hot air balloon came onto the scene. Inspired by toys such as sky lanterns, these vehicles took advantage of the fact that hot air rises. People would also eventually experiment with lighter than air gases like hydrogen or helium. And these really took off, if you will pardon the pun. Within 10 years, balloons were being used by some militaries to get a bird's eye view of the battlefield. For example, it's reported that during the American Civil War, the Union Army would send 1 to 5 people up in balloons as high as 300 meters using signal flags or telegraph wires to communicate what they were seeing and help aim artillery. These balloons were usually anchored to the ground, although there was one incident where a general decided to try it out for himself, only for the ropes to snap. He then found himself drifting over the Confederate army, who upon seeing an enemy general just hanging out above them, started taking pot shots at his feet. Also fun fact, Jules Verne, the writer behind 20,000 Leagues Under the Sea, wrote a sequel that starts with POWs escaping a Confederate camp in a hydrogen balloon. The plot goes on to be kind of a cross between the Swiss Family Robinson and the TV show Lost. Anyways, while the military was doing their thing, scientists also became enamored with these new balloons. Just a year after the first flight in 1783, scientists scientists were going up to study the atmosphere, as well as things like the Earth's magnetic field. Which brings us back to our story and the weird radiation in the atmosphere. It's 1911, and a man named Victor Hess was following the same logic that sent Wolf up the Eiffel Tower the year before. He took an open gondola balloon more than 1 kilometer into the sky and found that, once again, radiation levels didn't decrease the way everyone expected. Wolf, it seems, had actually been onto something. Subsequent flights by Hess and others suggested that even at altitudes as high as 5 kilometers, radiation levels actually increased. Where could this radiation be coming from? If it wasn't the air itself, well, there was only one thing higher than the atmosphere: outer space. In fact, we'd eventually start calling this mysterious radiation cosmic rays. But other scientists pushed back, suggesting that problems with Hess's instruments were to blame for his results. Over the next few years, the scientific community went back and forth on the issue. Measurements taken at even higher altitudes could help figure out who was right, but there's only so high an open-air gondola could go. Airplanes and uncrewed balloons could go higher, but some scientists still balked at the data, suggesting those balloons also had instrument errors. Scientists needed the kind of quality data that could only be provided by manually operated instruments, not automatic ones. But they needed it from altitudes no human had ever successfully reached before. Enter Auguste Piccard. Born in Switzerland, Piccard entered the world as just one of a huge family of nerds. His father was a professor of chemistry, and growing up, Piccard and his twin brother Jean both loved reading stories by Jules Verne. And Piccard loved balloons. He and Jean would make hot air balloons out of paper while growing up. And when he was a bit older, Piccard actually joined a group called the Swiss Aero Club, where he learned practical ballooning skills. He also served in the army as part of the Observation Balloon Corps. Besides balloons and adventure, Piccard, being the son of a university professor, had also grown up hearing about those strange cosmic rays. He decided one of his life goals was to investigate them himself, maybe even figure out a way to harness them as an energy source. So perhaps unsurprisingly, Piccard became a professor of physics at University of Brussels in 1922. 4 years later, Piccard discussed with his twin, who also had become a scientist and moved to the United States, the idea of a flight to study cosmic rays. In order to do so, Piccard would need to collect data from a region no scientist had successfully reached yet: the stratosphere. The stratosphere is part of the Earth's atmosphere and was first discovered in 1902. Its height depends on your latitude, from about 7 kilometers up, right at the poles, to about 20 kilometers near the equator. It sits right above the layer of the atmosphere we live in, called the troposphere. And unlike the troposphere, temperatures tend to go up as you ascend. The stratosphere has a lot of ozone, very little water, and basically no conventional weather. No rain or snow, and no clouds except rare ones above the planet's poles. Like, imagine being so high up you could look down and watch entire hurricanes and thunderstorms pass beneath you. That sounds awesome, as in the original meaning of the word, not like a hot dog with bacon on it. Now, the stratosphere is far above the death zone, where the air becomes so thin and so deprived of oxygen that humans cannot survive. But Piccard believed that if he could get up there, he could find new data on his beloved cosmic rays. If they really did come from outer space, this would allow him an opportunity to study them when they were fresh, so to speak, having penetrated only a little of Earth's atmosphere before the air could absorb nearly all of them. And beyond the science, there was still that romantic Jules Verne-style energy. Piccard wanted to show the world that the kind of amazing feats he read about as a boy were indeed possible, and encourage the burgeoning air industry to look to the high atmosphere as a possible realm of travel. So he began to design and build himself a balloon. Financed by the newly created Belgian National Fund for Scientific Research, Piccard added 2 key innovations to his balloon over existing models. The first was an invention that would dramatically save on weight. Instead of having the balloon surrounded by netting, he'd build the support for his gondola into the balloon itself. The second, and arguably more important one, was an airtight spherical aluminum gondola about 213 centimeters in diameter. Piccard himself was 198 centimeters tall, so for our American audience, the gondola was 7 feet in diameter, and the man was 6'6". Inside the sphere, oxygen would come not from the atmosphere, but from bottles of ultra-cold liquid oxygen to be opened and tipped out as needed. It would then instantly boil, since the boiling point of oxygen at a standard atmospheric pressure is like negative 183 degrees Celsius. In the meantime, any exhaled carbon dioxide would be removed via alkali scrubbers, devices that draw the dangerous gas out of the air via chemical reactions. Piccard took the technique from German submarines at the time. Thanks to the controlled conditions inside the airtight gondola, Piccard would not only be able to survive the dangers of the stratosphere, but could also bring up instruments so sensitive they could only normally be used inside a laboratory, not in the field. And once the balloon was built, Piccard just had to wait for an opportunity to use it. In 1930, an attempt on September 14th was canceled due to bad weather. But the following May, things were looking up. The weather the preceding days had been quote-unquote perfect, per reporting by the New York Times. And on the night of the 26th at 11 p.m., Piccard had his crew start filling the balloon with hydrogen. He hoped to lift off from the Riedlinger Balloon Factory facility in Augsburg, Germany early the next morning. Joining Piccard would be his assistant, Paul Kipfer, but even before they left the ground, problems started to occur. Though the weather had been good before, as the balloon started to fill, a wind kicked up and knocked everything around. A bunch of stuff got slightly battered, including the seal around an instrument built through the wall of the gondola, but nobody noticed at the time, and things seemed like they were all working correctly. Piccard and Kipfer ended up lifting off at roughly 3:55 that morning. It looked for a second like the balloon might hit the factory roof on liftoff, but they managed to avoid it and began to rise and rise and rise. They were expected to land about 8 hours later, around noon or the early afternoon, somewhere between the cities of Freiburg and Basel. But just in case, Piccard packed double the oxygen he and Kipfer would need for that length of trip. This decision turned out to be a good one, because as the two men were ascending into the atmosphere and starting to unpack and set up the instruments, Piccard started to hear a hissing sound. Remember that broken seal in the wall that nobody noticed? Air from inside the gondola was being sucked out through it. The airtight gondola that would let them survive the low-pressure atmosphere was no longer airtight. Piccard was able to stuff the leak with a mixture of Vaseline and loose cotton waste. But they were rising fast, and by the time the leak had been patched up, they were already in the stratosphere. In fact, the whole trip up only took about half an hour. Once at the top, things must have been looking up. Sure, the leak was unfortunate, but that was taken care of, and now they could marvel at what they'd achieved. Later, Piccard would write, "The beauty of the sky is the most poignant thing we have seen. It is somber, dark blue or violet, almost black." He described looking down and seeing the whole countryside below him, the snowy tips of mountains revealing themselves bit by bit above the foggy clouds below. There had been a few hiccups, but their trip up to the stratosphere had been a success. Piccard and Kipfer deployed their instruments and started to take some measurements, counting how many cosmic rays they were seeing pass through their cabin. Their trip down, however, would not be as easy. After a bit of time, Piccard went to release a bit of gas. Piccard and Kipfer's intention had been to take measurements at many different heights to build out a whole map of different radiation levels along their journey. And to do that, they'd built a valve into the balloon that they could use to release just a bit of gas at a time, which is how they planned to control their descent. But when Piccard went to pull on the cable that opened up the valve, it wasn't working. Perhaps that early wind had caused the cable to get tangled up in something. After more fiddling with it, the cable broke. What must it have felt like, seeing the only way to get back home just dangling there? With no way to control their descent, Piccard wrote in his notebook, "We are prisoners of the air." We'll be back with more of this wild story in a minute, but first, a quick ad. Thanks for watching SciShow. We've heard you loud and clear that the SciShow audience loves rocks. That's why we keep making new Roxbox videos, highlighting another geological marvel every month. And to go along with those videos, we send Roxbox subscribers a sample of whatever mineral or fossil we talked about in that month's video right to your door. In your Roxbox, you can expect everything from fool's gold to emeralds to trilobites. The Roxbox is so popular that we've had a wait list in the past because we can only source so much of each rock, but right now we have rocks to spare, so if you've been hoping to get your very own Roxbox, now is the time. Find the monthly Roxbox subscription, individual samples, and Roxbox merch at complexly.store/rocks. Now everything that goes up must come down, and as scientists, Piccard and Kipfer knew there was an out. Gases expand when heated and contract when chilled. With the sun outside heating their balloon during the day, the gas would stay heated and stay aloft. But as the sun set, the gas inside the balloon would start to condense and lose buoyancy. The problem was that they would have to wait the hours it would take for that to happen, all on a limited supply of oxygen. Oh, and the air leak reappeared too. So the struggle for life began again, Piccard would later write. Unfortunately, that wasn't the end of their bad luck. To make things worse, at some point, a barometer inside the gondola shattered and spilled some mercury on the floor. Mercury can chemically react with aluminum and might have started to eat a hole through the gondola's floor if it weren't for a thick layer of paint coating the inside. Nevertheless, mercury isn't exactly a good thing to just have splashing up around your feet as you walk around. So Piccard turned into Angus MacGyver once again. Ask your parents. He took a hose connected to the atmosphere outside, and since the outside had so little air pressure, when he opened it up, it was kind of like opening up a tiny airlock to outer space. The hose was turned into a makeshift vacuum. A bit of their oxygen was lost, but most of the mercury was sucked right out. Not all of it, but most. Which leads us to the next problem they discovered. They had no water. They were supposed to have 2 large bottles of drinking water to split between the 2 of them, but instead they discovered they only had 1 small one. There was some water that had collected at the bottom of the gondola from their breath, and they could have theoretically used that to quench their thirst, but that stuff was full of dust and the rest of the mercury that Piccard wasn't able to vacuum out. It was bad, but their thirst was going to get worse, because by 12:30 p.m., the mechanism meant to regulate the temperature inside the gondola broke. The gondola's exterior had been painted black on one side. Darker colors absorb more of the sun's energy, so if it got too hot, Piccard simply had to rotate the whole thing so the shiny aluminum side pointed toward the sun, and vice versa. But when they went to test it, the motor wasn't working, so the temperature went up and up. At one point, the inside of the gondola reached over 40 degrees Celsius. Piccard described it as unpleasant. Eventually, around 2 p.m., they started to descend, but it was slow going, so let's check in on the ground. Piccard and Kipfer were supposed to have landed by now, and there was no radio to communicate with them to learn what went wrong. 2 airplanes were sent from Germany to try and make contact with Piccard, but they couldn't reach the necessary altitude. So by the evening, everyone on the ground was totally convinced the scientists were dead. A reporter from the New York Times wrote that, quote, even the makers of the Stratosphere balloon had given up hope. Back in the sky, the balloon was now slowly descending, and as the sun went down, the heat was finally relenting. But this only led to another new problem. At first it was too hot, now it was too cold. It got so cold, in fact, the moisture in the air started to freeze to the walls and instruments, with Piccard comparing it to snow inside the cabin. Sounds miserable, but at least this kind of solved their water problem. They could scrape frost off the inside of the gondola caused by their own breath. This is how they had to exist for hours. But eventually, their rate of descent started to pick up, and around 8 p.m., they returned to the troposphere. They were right that the cool of the evening would get them back to Earth, but they still had to be careful. While they were headed in the right direction, that broken valve meant they couldn't control how fast they were descending. They could jettison some ballast to make sure they didn't crash. That is to say, just throw stuff off the side. But if they lost too much weight, the balloon would start to rise again. Meanwhile, Kipfer had been keeping a close eye on the barometer, and when they hit an altitude of around 4,500 meters, he called out that the air pressures inside and outside the gondola had finally equaled out. After 17 hours of being sealed inside the gondola, the 2 scientists could finally open up the portholes and stick their heads out to breathe fresh air. By this time, they only had 1 hour of oxygen left. Without Piccard's foresight to double up just in case, they would have suffocated to death hours ago. He would later write, above us, the starry sky, beneath the high mountains, snow and rocks. The moonlight was magnificent. They saw distant thunderstorms and the mountains, the peaks of some already towering above them as they fell. The 2 men weren't done yet though, and Piccard knew the next few minutes were going to happen fast. They were going to land somewhere in the mountains. It was probably going to be a rough landing no matter what, but if Piccard and Kipfer were careful, they could avoid smashing into a field of jagged, bone-breaking rocks or disappearing down a glacial crevasse. At one point, they even bounced off a steep snowfield, but Piccard kept his nerve. Eventually, he saw a smooth stretch of glacier beneath the balloon. He pulled a ripcord, releasing the entirety of the balloon's gases. And at roughly 9 p.m., the balloon finally came to rest on the Gurgel Glacier in Austria. Piccard later later said, "We jolted slightly when the gondola scraped over the glacier, but the balloon was scarcely damaged." Far away from any rescue, Piccard and Kipfer wound up spending the night on the glacier, using balloon material as a blanket. In the morning, they cooked themselves a meal of arrowroot mixed with glacier ice before starting the hike down to the village of Obergurgl. And halfway through their journey, they were caught by a rescue party who'd seen the balloon go down, led by the village schoolmaster. Piccard and Kipfer ultimately arrived in the village at 5 p.m. They then made their way to Brussels, where they met with politicians, students, even the king and queen, not to mention their families. And eventually, they went back up and retrieved the balloon from the glacier as well. So what happened after? Well, first off, Piccard and Kipfer's altitude record of 15,781 meters was accepted by the Swiss Aero Club. But what about the science? What about Piccard's beloved cosmic rays? Unfortunately, between all of the hullabaloo, the scientists only took one radiation measurement right at the peak of their flight at just shy of 16,000 meters. After some recalibration on Earth, Piccard found the data did match what Victor Hess had predicted. Cosmic rays really were coming from outer space, according to that one measurement. If you're a good scientist, that isn't enough to say anything definitive. But as far as single data points go, it was a tantalizing one. Piccard would fly again the following year, going even higher into the stratosphere. Thankfully, the flight was much more boring and yielded much more data. Within a few years, thanks to Piccard and other balloonists, as well as improvements to uncrewed balloons, a conclusion was finally reached. Today, we know that most cosmic rays are subatomic particles that get shot across the universe from things like supernovas at nearly the speed of light, only to crash into our atmosphere where they explode in a shower of gamma rays and other high-energy particles. As for Piccard, he dreamt that his success would encourage nearly all future air traffic to reach the stratosphere. That future has not arrived yet, if it ever will. We still tend to stick to the troposphere, but some modern airplane trips may go through the very lowest bit of the stratosphere. Eventually, and apparently not satisfied with conquering the skies, Piccard turned his sights to creating an airtight vessel that goes down, the bathyscaphe. In 1953, he and his son Jacques took a bathyscaphe to a record depth of 3,150 meters. And as inspired by Piccard was by the likes of fictional explorers, he too became the inspiration for others. The Professor Calculus character in the comic series Tantan was explicitly based on him. And yes, there is a certain Star Trek captain who shares his surname, with a slight shift in spelling, although it isn't quite clear from the historical record which, if any, member of the Piccard dynasty Jean-Luc Piccard was named after. So that's the story of why humanity's first visit to the stratosphere was kind of a disaster. A scientific expedition with lofty goals, only to be spoiled by a loss of control, emergency leaks, crash landing, and what must have seemed like a return from the dead. But hey, no one died. And even though Piccard wasn't able to accomplish that much science on the trip, he still helped solve a decades-long scientific mystery and proved that the kinds of expedition he dreamed of as a kid were indeed possible.